Generation Zero. This is where it all started, and it was not pretty. Born in the 1930s, Generation Zero night vision was developed by Nazi Germany and later copied by the Allies during World War II. It did not amplify existing light. Instead, it blasted the darkness with massive infrared searchlights mounted on flatbed trucks, beams so large and so obvious they might as well have had a sign saying, "Shoot here." Soldiers could see in the dark. The enemy could see the trucks. The image was grainy, the range was short, and the whole system weighed more than a motorcycle. But it proved one thing: whoever owns the night wins the fight. That idea never went away. White phosphor goggles. For decades, night vision showed the world in green. Green was chosen for a simple reason. The human eye can distinguish more shades of green than any other color, making it easier to spot movement and contrast in darkness. Then came white phosphor, and the green world became a black and white one. White phosphor goggles produce a grayscale image, sharper, with more contrast and more natural-looking depth. Targets that blurred into the green background now stand out in crisp shadow and shade. Operators running long patrols reported another advantage. White phosphor causes significantly less eye strain over hours of continuous use, in some cases extending comfortable wear from 4 hours to 10. Today, white phosphor is the standard for special operations forces worldwide, replacing green across elite units who spend entire nights behind their goggles. Quad-tube night vision. Standard night vision goggles give you 2 tubes, 2 eyes, roughly 40 degrees of vision, a narrow tunnel that forces you to constantly turn your head to see what's next to you. Quad-tube systems fix that by adding 2 additional image intensifier tubes on the outer edges, stitching 4 separate images together into a single seamless panoramic view. The result is roughly 97 degrees of field of view, more than double what standard goggles provide. In a fast-moving, close-quarters environment, that extra peripheral vision is not a luxury. It is the difference between seeing a threat at your side and not seeing it at all. The trade-off is weight, cost, and complexity. A quad-tube system can run over $40,000. It is overkill for most situations and absolutely essential for a few specific ones. Thermal scope. Every other night vision device on this list works by collecting and amplifying light. Thermal works on an entirely different principle. It does not need light at all. Thermal imaging detects heat signatures, the infrared radiation naturally emitted by living bodies, running engines, and warm objects. A person hiding in total darkness behind a bush is invisible to standard night vision. To a thermal scope, they glow like a lantern. Thermal is the reason no amount of camouflage, darkness, or concealment fully protects you from a modern military equipped with it. It sees through smoke. It reveals footprints on cold ground. It finds people who think the night is protecting them. The limitation. Thermal cannot read fine detail the way image intensification can. It tells you something is there. It does not always tell you exactly what it is. Fusion night vision systems. The logical conclusion of combining 2 technologies that each see what the other misses. Fusion systems merge a traditional image intensification channel with a thermal imaging channel into a single display. The result is a picture that has both the clarity and fine detail of standard night vision and the heat-detecting power of thermal, simultaneously. An enemy hidden in darkness, behind cover, wearing the right gear might fool one system. Fooling both at the same time is close to impossible. The U.S. military recognized this and made fusion the direction of next-generation night vision development. The ENVG-B, covered shortly, is the most advanced fielded example of this concept. Fusion systems represent the moment night vision stopped being about seeing in the dark and started being about making hiding in the dark effectively impossible. Helmet-mounted night vision. Before helmet mounts, night vision was handheld, scope-mounted, or strapped awkwardly to the face. Moving with it was dangerous. Using your hands for anything else was nearly impossible. Helmet-mounted systems changed the entire way operators moved and fought at night. By attaching night vision to a helmet via articulating arms and dovetail mounts, operators could flip the device up when not needed, keep both hands free for weapons and equipment, and move at combat speed through complex terrain without removing or managing a separate device. The evolution from a handheld tool to a helmet-mounted system is arguably as significant as any improvement in the optics themselves. It turned night vision from something you look through into something you wear, a permanent piece of the operator, available in a fraction of a second. A N/PVS-31, the Special Forces Binocular. This is the standard binocular night vision device of U.S. Special Operations Forces, the one operators across Delta Force, SEAL teams, and Ranger battalions actually wear on missions. It was designed with direct input from those operators, and it shows. The PVS-31 is one of the lightest dual-tube night vision systems ever built, weighing just under 1 pound, despite fitting 2 full Generation 3 white phosphor image intensifier tubes inside. Its tubes can be run binocular for depth perception, or one can be flipped up for monocular use when transitioning between dark environments and light. It was built to replace the older PVS-15 with one goal: the same capability in a significantly smaller, lighter, and more balanced package. When operators are running all night, grams become everything. ENVG-18, the Panoramic. This is the four-eyed goggle you have seen in photos of special operations raids, including replicas worn in the film depicting the raid that killed Osama bin Laden. 4 tubes, 97 degrees of panoramic view, white phosphor throughout. The ENVG-18 was developed alongside USSOCOM to give operators the widest possible situational awareness at night, without turning their heads. Each outer pod can even be detached and used as a standalone handheld device. At over $40,000 per unit, the ENVG-18 is not standard issue. It is the equipment of Tier 1 units performing the most demanding missions on the planet, where knowing what is at your left and right edge is not a preference. It is a survival requirement. ENVG-B, the future of night vision, the enhanced night vision. Goggle binocular is what happens when the military stops choosing between thermal and image intensification and decides to have both, fused, helmet-mounted, and wirelessly connected to a weapon sight. The ENVG-B combines white phosphor image intensification tubes with a thermal imaging channel, blending both into a single display. Soldiers can see the detail of standard night vision while simultaneously detecting heat signatures. Targets are identified faster, at greater range, and with more certainty than any previous system. More than 10,000 U.S. Army soldiers have been issued the ENVG-B. It has since been supplied to Ukrainian forces as part of Western military assistance, where its performance has been documented in real combat against a peer adversary equipped with older generation Russian systems. The gap in capability between the two sides on those nights is not subtle. PNV-57, the Soviet answer. While the U.S. was refining its night vision technology in the 1960s and 70s, the Soviet Union was doing the same. On the other side of the Iron Curtain, the PNV-57E was produced from the 1960s through the 1980s, initially issued to helicopter pilots and tank crews. It is a Generation 1 Plus binocular system, 2 separate tubes providing basic stereoscopic vision, powered by a cable connected to a vehicle's instrument panel or, in a pinch, a 9-volt battery. It was the most widely used night vision device in the Soviet armed forces. It saw its first combat during the Soviet-Afghan War, where it encountered an enemy that had none. Today, it is a collector's item and a video game prop, but its existence is a reminder that the race to own the night was never just American. 2 superpowers built parallel paths into the dark, and those paths shaped the world's night vision technology for generations. Outro. Which of these systems do you think changed warfare the most? the fusion technology of the ENVG-B, or the panoramic view of the quad tube? Let us know in the comments and subscribe so you don't miss the next one.